Hello class, in this video we are going to learn about subtopic 6.7 neutralization per neutralan still in chapter 6 acid, base and salts. So in this content standard, what you are going to learn is about 671, state the meaning of neutralization, and then determine the concentration of an unknown solution through titration method, and also solve numerical problems involving neutralization. Okay, so these are the three learning standards that you are going to understand in this video. This is in your textbook, page 167. Okay, neutralization dalam bahasa Melayu peneutralan. Okay, so these are the two different pictures that you see. One is a bee and one is a wasp. Okay, so according to the notes here in your textbook, when stung by a bee, the area that had been stung can be treated by baking soda. Vinegar, on the other hand, is used to treat the area that has been stung by a wasp. Why? Okay, so as you all know, seperti yang kamu sudah tahu kan, baking soda is a type of alkali. Vinegar is a type of weak acid. If we use baking soda to treat the area yang kena sengat oleh bee, maksudnya sengatan bee adalah berasid, because we need to treat it with an alkali. Dan sebaliknya, if vinegar, cuka, digunakan untuk merawat kawasan yang disengat oleh lebah, so what we do, we use vinegar, maksudnya sengatan ini adalah bersifat alkali. Because we need to use different bahan yang bertentangan, asid dengan alkali. Kenapa? Supaya dia neutral. Let us look at the definition of neutralization first. So, apa itu peneutralan? It's a reaction. Ia adalah satu tindak balas between acid and alkali. Alkali itu base lah. Alkali adalah base yang larut dalam air. To what? To produce salt and water only. Untuk menghasilkan garam dan juga air. So, peneutralan adalah tindak balas antara acid dengan alkali. To produce salt and water only. In this reaction, the salt and water produced are neutral. This is neutral because acid lose its acidity and alkali lose its alkalinity. Kedua-duanya sudah hilang sifat asid dan sifat alkali, dan bila bergabung sudah menjadi neutral. Dalam bentuk apa? Bentuk garam. For example, the neutralization reaction between nitric acid, this is nitric acid, HNO3, with potassium hydroxide, KOH, to produce potassium nitrate and also water. Look at this neutralization here. Okay, we have this H is the H plus and then NO3 minus. This one is K plus and also OH minus. What happened here is the hydroxide and hydrogen is going to combine to form water, whereas potassium and also nitrate are going to combine to form potassium nitrate. This is the salt that you obtain and it's neutral. In neutralization, the actual reaction that occurs only involves the combination of hydrogen from the acid and the hydroxide ion from the alkali to produce water molecule. Hence, the ionic equation is as follows. Okay, so let me explain this one, how the ionic equation for neutralization can be obtained. Bagaimana kita dapat memperoleh persamaan ion. Okay, persamaan ion adalah persamaan yang ada charge. Okay, charges on the bahan-bahan dia. Okay, first thing first, you need to have the chemical equation. So in the chemical equation, you need to ionize it. Okay, ionize maksudnya apa? You need to keluarkan dia punya ion-ion yang ada di dalam bahan-bahan itu. Contoh, HNO3 ada H plus, ada NO3 minus. KOH ada K plus, ada OH minus. And then KNO3 ada K plus, ada NO3 minus. And H2O ada liquid. Okay, kenapa begitu? Begini. If you want to make the ionic equation, right, you need to see this condition. This is aqueous, this one also aqueous, and this one also aqueous. So what you do, you need to pisahkan dia kalau dia adalah aqueous. Kalau aqueous, tapi if it's a solid, liquid, gas, tidak payah pisahkan dia. Maksudnya tidak payah bentuk dalam bentuk ion. Tidak payah. Biarkan dia dalam bentuk yang asal, iaitu solid, liquid or gas. Apa contoh gas? Contohnya carbon dioxide, oxygen, like that. So, if you see the condition, dia punya syarat tu, dia punya keadaan adalah dalam bentuk solid ke liquid gas, jangan kacau. You only kacau the aqueous one. And from the aqueous, you need to pisahkan dia. Okay? So, now, you need to cancel out. Cancel apa? Cancel yang sama. Sama di sebelah kiri anak panah and also di sebelah kanan anak panah. Di sebelah kiri, you have nitrate. Nitrate, di sebelah kanan, you also have nitrate. Potong. Sebelah kiri anak panah, this is anak panah, right? Okay, sebelah kiri anak panah, you have potassium ion. Sebelah kanan pun ada potassium. So, cancel it out. What the girl said here? Potassium and nitrate are considered as spectator ions that do not change in the reaction. Tidak berubah. Tidak berubah. So, we call them spectator ions. Thus, these ions are cancelled out in the equation. We cancel them out. Kita mansuhkan dia. So, apa yang tinggal? Yang tinggal is H plus or H minus and air. So, this is the ionic equation untuk semua. For all neutralization reaction. Okay? Now, this is one work that you need to do. Activity 6.10. Write a complete equation, a chemical equation, and ionic equation for neutralization reaction. Okay? And then, you need to complete and balance it. After that, write the relevant ionic equation. Okay? Let us continue to this page 169 in your textbook. Let us look at what are the applications of neutralization dalam kehidupan harian kita. So, figure 6.31, these 4 figures showing the application of neutralization for a variety of uses in daily life. Yang pertama, we use medicine. Dan dalam medicine ni, contoh, milk of magnesia, magnesium hydroxide. If you use hydroxide, hydroxide ni adalah alkali. Relieves, okay, melegakan gastric pain by neutralizing the excessive hydrochloric acid in the stomach. Our stomach can produce hydrochloric acid. So, when you have gastric pain, you actually have excessive, terlampau banyak HCl inside your stomach. What you do? You eat medicine yang mengandungi milk of magnesia, which is magnesium hydroxide. Hair health. Okay, in shampoo. Weak alkali in the shampoo neutralizes acid on hair. Okay, ada asid pada rambut kerana berpeluh, macam-macam lagi pendedahan terdedah di luar sana yang menyebabkan rambut berasid. Okay, so what we do? How to neutralize it? We use weak alkali. Di mana? In shampoo. Dental health, kesihatan gigi. Toothpaste contains a base that neutralizes lactic acid produced by bacteria in our mouth. Mulut kita ada asid lactic. Sebab itu berbau pagi-pagi. So what we do? Neutralize that by using toothpaste. Kenapa? Because toothpaste ada base. Okay, this one. Slag lime, which is alkaline, is used to treat acidic soil. Soil, tanah. Tanah apa yang berasid? Kenapa tanah boleh berasid? Hujan asid. Salah satu sebabnya. Dan juga pengaliran bahan-bahan kimia daripada kilang-kilang. Jadi kita punya tanah pun berasid, tidak sesuai untuk menanam. So what we do? How to neutralize that so that agriculture can continue smoothly? How? We use alkali dalam slag lime. So those are the application of neutralization in daily life. Okay, now that you learn the meaning of neutralization and also you know what are the application of neutralization in our daily life, now let us learn about how to determine the concentration of an unknown solution through titration method. Sekarang ni kita akan belajar tentang kaedah pentitratan dalam Tajuk penyutralan. This is in page 170 in your textbook. So let us look in detail apakah maksud titration method. Titration method is a quantitative analysis method to determine the volume of acid needed to completely neutralize a given volume of alkali and vice versa. Ini adalah satu kaedah analisis kuantitatif untuk menentukan volume of acid ataupun isi padu asid yang diperlukan untuk meneutralkan satu alkali yang diketahui dia punya volume ataupun vice versa, sebaliknya. Okey, ini adalah gambar aja, the figure for titration method. This is a burette filled with acid. The acid is going to be titrated, dropped inside the conical flask containing potassium hydroxide solution. Ataupun sebaliknya pun boleh. Isi alkali di sini untuk neutralkan asid pun boleh juga. Okay? Now, activity 6.13 sangat jelas, and I attach one video in your Google Classroom about these titration procedures. Please watch the video as well. Okay? Activity 6.13, before that we look at the note over here. I almost forgot. In acid-base titration, kita panggil pentitratan acid-base. A solution of known concentration is slowly added from a burette. Maksudnya, di dalam burette ni kita tahu berapa kepekatan asid. Kita tahu okay? Lepas tu, itu akan di-titrate. Dijatuhkan drop by drop. Drop by drop ke mana? From a burette into a conical flask that contains a volume of alkali of unknown concentration. Nah, so now we know that this is alkali and we know the volume. Berapa volume dia? Iaitu 25. But we don't know what is the concentration. So from this method, kita sebenarnya boleh jangkakan berapa kepekatan ini, berapa volume ini, supaya kedua-dua ini homogeneous, kedua-dua ini neutral. Acid meneutralkan alkali. Okay. So what you need? Okay, the aim here is to determine the concentration of KOH by acid-base titration. Alright? I almost forgot this note over here. Titration stops as soon as the acid-base indicator changes color. You understand that? Prosedur ini akan berhenti apabila kamu nampak perubahan warna. Warna apa? This one. The point in the titration at which the acid-base indicator changes color is known as the end point. Itu adalah takat akhir. Bila kamu nampak ada perubahan warna yang terjadi di sini, okay, as in this picture, it showed here pink color. So, sebenarnya, bila satu takat akhir sudah dicapai, the end point is reached, maksudnya, kedua-dua ini sudah homogeneous. Okay, di dalam conical flask ini sudah neutral. So, how to know that dia sudah neutral? We will see the color changes from pink to colorless. Okay, pink to colorless. So, bila nampak itu pink color sudah change to colorless, stop lah. Stop. End point sudah. You reach the end point. Titration, done. Neutralization, achieve. Begitu maksudnya. Okay, materials needed, 1.0 mole per cubic decimeter nitric acid. Okay, ingat we know the concentration of the acid. And then, potassium hydroxide, you don't know the concentration. You have an indicator, phenolphthalein and distilled water. Indicator mesti ditambah. Kenapa? Kalau tiada indicator, you will not know that habis sudahkah kita punya tindak balas. Boleh sudah kita stop like that. You need to have phenolphthalein indicator. Kalau tidak, you will not have this alkali changes to pink. Kalau dia tidak berubah jadi pink, dia masih lagi colorless. Ini pun colorless, kasih drop di dalam, mana nampak perubahan. So, you need the phenolphthalein as an indicator, sebagai penentu dia. Okay, procedure. What you do? Rinse a 25 cubic pipette with a little potassium hydroxide and remove the solution. So, apa kamu buat di sana? You use a pipette. You use a pipette. Okay, if you don't know what is pipette, I show you now. This is pipette. So, there are 3 types of pipette. Ada yang can measure 2 cubic centimeter atau 2 ml, 10 cubic centimeter or 25 cubic centimeter. So, in the experiment, in your textbook, dia mau kamu rinse 25 cubic centimeter of pipette with a little potassium hydroxide. You have to rinse. Kenapa guna pipette? Because pipette sangat tepat. Dia sudah ada isi padu yang ditetapkan. Ngam-ngam. So, you no need to susah-susah pakai measuring cylinder. No need. Sebab sudah ada pipette. Okay. So, you rinse first the pipette. Kemudian, remove the solution. So, you pipette exactly 25 cubic centimeter of potassium hydroxide solution. Transfer into a conical flask. After you transfer into the conical flask, what you do is you need to add a few drops of phenolphthalein indicator into the potassium hydroxide solution. Okay, tuang dulu dalam ni potassium hydroxide and then titiskan few drops of phenolphthalein. Then you will see tu dia punya color change to pink. Okay, and then you rinse a burette with a 1.0 mole per cubic decimeter of nitric acid. Why you need to rinse the burette first? Because kita mau buang dulu benda asing di dalam. Kita rinse dulu dengan bahan yang kita mau tuang. So you rinse first. After you rinse, you remove the whole solution. Then baru you fill in the burette with 1.0 cubic mole per cubic centimeter of nitric acid. And then you clamp the burette onto a retort stand. Record the initial reading. Don't forget to record the initial reading. Mesti mau ada bacaan awal kan, because later after we titrate you are going to see changes tu, dia akan turun sikit. So drip 1.0, titiskan 1.0 mole per cubic decimeter of nitric acid slowly into the conical flask while swirling it. Maksudnya sambil kamu goyangkan dia. Okay, you can see that in the titration procedure that I attach in Google Classroom. Okay, then you will understand better. And then you stop adding 1.0 the acid. Stop adding the acid as soon as the color of the solution changes from pink to colorless. As soon as the color berubah from pink to colorless, terus stop. Jangan lagi tambah di dalam. Okay, record the final burette reading. So, dia punya bacaan akan menurun lah. From here, maybe akan turun ke sini. So, you record what is your final reading. Calculate the rough volume of 1.0 mole per cubic centimeter nitric acid that is needed for titration. Okay, kamu perlu kira. Tolaklah, tolak. So, repeat steps 2 and 3. What is steps 2 and 3? 2, you need to pipette again potassium hydroxide here. Okay, and then you need to put a few drops of phenolphthalein. You repeat again. Step 2 and 3. And then flow 1.0 mole per cubic decimeter, the acid just now, until the volume. Okay, until the volume tadi. Volume tadi itu adalah V. V adalah volume yang kita dapat daripada titration yang awal-awal tadi tu. Okay, into the conical flask containing 25 cubic centimeter of potassium hydroxide. Then stop the flow. Okay, you need to do this one because we need to have apa dia punya isi padu yang diperlukan untuk meneutralkan potassium hydroxide. 25 cubic centimeter padu. This V, remember, this V is coming from the first step yang awal-awal kita buat, the titration. After you get it, and then kamu perlu repeat step 2 and step 3. And then after that, you need to stop the flow. Subsequently, add 1.0 mole per cubic centimeter nitric acid drop by drop into the conical flask. Sama juga, and occasionally rinse the inner surface of the conical flask with distilled water to make sure that all of the nitric acid has been titrated into the KOH. Stop the titration as soon as the color turns colorless. You need to do at least 2 times. Okay, 2 times. Record the final burette reading. record. And then repeat again. Step 9 until step 14. Why? Because, okay, the first one that you do is the rough volume. And then you need to repeat 1 kali, 2 kali, 3 kali. Why do we need to repeat that a lot of times? Sebab kita mau jumlah yang tepat bah. Kita mau yang paling tepat sekali. What is the volume needed? You need to tambah bahagi 3. Macam begitu. Macam ni. What is the average volume of nitric acid that is needed? So, apa average volume dia? By ignoring the rough volume. Ini jangan tengok. So, katakanlah you dapat here 25, 24, 23. Kan kita buat 3 kali. So, mungkin bacaan tu is different in each sets. So, what you do, you need to tambah all these and then bahagi 3. So, that is the average volume. Okay, write the ionic equation. Ionic equation, kamu sudah nampak kan tadi? Okay, you have seen the ionic equation just now. How I taught you in the middle of the video. Okay, calculate the number of mole needed in this neutralization reaction. Number of mole kalau solution, you remember you use N sama dengan MV. Calculate the number of mole of potassium hydroxide. Sama juga. Determine the molarity. Molarity maksudnya you have to determine apa kepekatan dia. Okay, so you try to watch the video first and then you try to answer all of this question. Okay, you need to prepare a complete lab report and attach it in Google Classroom. Okay, now let us go to this note over here. This one is in page 172 textbook.